Dropbox, which is some files out on the cloud. Dropbox. Oh, I guess this is apps. Dropbox. And so I'm going to pull up what I need as I go along. Yeah, I am kind of showing off and trying to impress you, but the reason is not me. I just want to lend some extra credibility to what I'm saying. So, let's look at what's been happening. I'm actually going to begin with something else. Let's see. Here we go. That's what I want to get. Yeah. I'm going to get that big on the screen. Okay, now what you're seeing here are how do we know that we're in a warming world? How are people going to tell? I mean, we say that. We talk about taking the temperature. And what are the signs? What are we going to see if that happens? Well, these are 10 indicators. This is what the scientists look at to corroborate that the hypothesis is correct. They look, what we're saying is that CO2, and I won't go into this, carbon dioxide, is what's called a greenhouse gas. All that means is that in a greenhouse, you put plants in a greenhouse because you get a warmer environment year-round. So greenhouse gas means that the atmospheric CO2 traps the heat, or the light, which is simplistic and not exactly 100% right. What happens is the light coming in is actually transformed into heat by the surface, which heats up, and also by the atmosphere itself. And CO2 has this propensity for trapping the heat and the reflected light and converting it to heat. How do we know this? Well, back in the 1850s, some guy pumped a bunch of CO2 into a glass cylinder, put a thermometer in it, and then basically shone the light through it, and it heated up. You do the same thing with nitrogen, because the air is not primarily oxygen, it's primarily nitrogen, or maybe 20% oxygen, roughly, and it doesn't heat up. The light just passes right on through. So we do know that carbon dioxide will convert light into heat. And in fact, light and heat, from a physicist's perspective, are actually the same thing, but different flavors of the same thing, called electromagnetic radiation. And then, what would the impact of heating the atmosphere to global warming? What would that do? Well, that would cause things like the sea surface temperature to rise, sea ice to melt. What do you think sea ice melting will do to the ocean level? Anyone? Okay, that's the answer I expected, but that's what happens when you put an ice cube in glass as it melts to the level of the water. Yeah, exactly. It's not the ocean ice that we're concerned with, it's the land ice, the glaciers and that stuff melting. What happens, do you have any idea of what happens to an object when you heat it usually in terms of its size?
It expands.
It expands, exactly. The same thing happens to ocean water. So you have two effects going on here in terms of heating up the oceans. One is melting the ice around the oceans in the peripheral areas. Melting the sea ice also has implications because that's largely fresh water and it changes the salinity of the ocean and does other things. And then also just that vast body of ocean expands. And it expands more than people. I heard a denier the other day saying, well, okay, I'm not really a denier. I'm saying, so what? So the ocean has changed 0.18 degrees over the last century. What does that mean? Well, when the oceanographers gave that number, it was for an ocean that was a half a mile deep. And it turns out that an expansion, if you look at the expansion coefficient, and there's some discrepancy, people disagree by orders of magnitude, not orders of magnitude, by 3 to 4 times, by a considerable amount of uncertainty. But it does expand a lot, and expands to 10 feet high, because that's a very large amount of water that's heated up. So you got two things going on. You have the ice and snow melting and going into the ocean, adding more water, and you have the water going up, even with a small temperature degree. Okay. So the sea level is one measure, and we're going to stick with that. Okay. We're going to stick with that because that's an easy way to explain what the economic impact of all of this is. All right, let's see if I can get to something else here.
I just wanted to mention that one of the problems we face here in Prince George's County is that we have a very large oceanfront area. And we're getting, because the water is, because the
We
water
have
is...
no oceanfront here.
Well, not oceanfront, but a waterfront front area.
Yeah, tidal basin.
Right, and because of that, the water comes up further. It's starting to impact the structures that we have in the state. And well, Stephen, are you ready for your next slide? I mean, that's why this is critical to Prince George's.
Okay, I'm actually picking these out as I'm thinking about what I want to say. This might be worth showing. Okay. What you're looking at here is a chart of, let's see if this does any better. That makes it, yeah, that gets a little better. Okay. What you're looking at here is actually the change in sea level. How far up it's going, okay? And this goes back to 1870. We didn't have satellites in 1870, clearly, but this is prepared by my colleagues in Australia. And what they've done is they've taken all the available measurements they could get for what's called tidal gauges. Most of you know what